Question 11 on pulleys then. We've got to complete the force diagram. So I've copied and pasted it over here to make it bigger. So looking at all the forces on the ball, first of all, we're going to have mg as the weight going down. There'll be the tension here. There'll also be a tension here. It says it's an inextensible string, so we know the two tensions are going to be equal. There's going to be the weight of the block, which is 2g, normal contact force of the block, which is r, and it's the pulley is smooth, but the table is rough, so there will be a frictional force going in that direction. So I think that's all the forces marked on the diagram now. So let's do part 2 then. So in part 2, we're told the whole system is in equilibrium. So if we look at the well, what do we need to know? We need to know the frictional force. So in order to find the frictional force, we're going to need to use F equals mu r, and we know that mu, it tells us in the question somewhere, the coefficient of friction is 0.6. So we know mu is 0.6. So what we've got to do is find r first of all. So if we can find r, we could just times it by 0.6, and then we've got the frictional force. So in order to find r, we can resolve vertically on the block, and since it's not moving in that direction, we know that all the forces going up, the upwards forces, which are r plus, and then this force here, that force there is going to be 5 root 2 sine 45. So that force there plus r, those are the two forces going up on the block, and they will equal the forces going down, which is just the weight of the block, which is 2g. And so if we do 2g minus this, we'll get the value of r, which should be 14.6 newtons. And so then, as we've discussed, we can now use this formula, F equals mu r, so F equals 0.6 times by r, and that will give us a frictional force of 8.76 newtons. So last part of the question, part 3, I've got to calculate the value of m. In order to find the value of m over here, we're going to need to find the tension first. Okay, so let's find the tension by resolving horizontally up here. So we're going to find the tension. We're going to do that by resolving in horizontally on the block. So if we do that, we'll get all the forces going to the right, which is T, nothing else. That will equal all the forces going to the left, which will be the frictional force, plus we've also got this component here, and that's going to be 5 root 2 cos 45. So 5 root 2 cos 45. We know what F is. We know F is 8.76, so we can put that in there, and that will tell us what the tension is, which you should work out as 13.76 newtons. And so the last bit, we need to then resolve. We need to resolve vertically over here to find out what the value of m is. So if we now resolve vertically on the ball, we'll get all the forces going up, which is T, equal all the forces going down, which is the weight mg. We know what T is, 13.76. We don't know M, but we do know G. So M will be 13.76 divided by 9.8. So M will be 1.40 kilograms. 2 3 significant figures.